artist again have to push the other. Because doing this right again tough job. So wherever we please told us, sometimes we will take an image. So what we will do is that today evening we will take a copy of working image. Okay, then we will try to push wherever it's not comfortable. So that by tomorrow you won't have any problem. Because you will be doing some afterward termination or something, the image may not have properly closed. So this type of issue may be there. Right?
Lastly, you told us if you create the images, usually it takes the similar size on all the shows, right? But in my machine it was 58 GB and in this machine it was 58. So why is it not different? Consideration of the
It should be like the same, some variation will be there, here and there some changes will be there, because according to the job which you are doing, some files you are going to create, maybe some log file, how long the explanation is going to be, the size of the log file, how long you are going to, for example, if you started a custom for NGS next, what happens, it will be generating a lot of log file. If you shut down your application, it may not generate log file. So, that may be really.
खाली कौन कौन से कल हम चक्का के सब तो खुल गया हम हाँ कल रात में चीज आएंगे हम लोग क्या खाने के लिए क्या है नहीं यार कुछ भी टिफिन है ककम्बर पहुंच मार दी पड़े स्टॉप मार बहुत बड़े मोना का लगा पहुंच वाले में सीख तो से पहुंच में जो हां पहुंच मार के हर बोली सब डाउन करना करता है पहुंच मार मंजू काम करना कितने लोग स्टार्ट कोर्स ऑलरेडी स्टार्टिंग है तीनटा स्टार्टिंग बा तीनटा स्टार्टिंग এইটা দেখো তোমার স্টার্টিং একটা তো স্টার্টিং তিনটা ডিসে করো তারপরে লাস্ট में দেখি দাও ঠিক দুইটা বাকি আছে এন্ড ইউ ক্যান মেক ইট কইছো লাগে তিনটা फॉर्मेट पता है केबल नहीं बस रे हमें गाड़ी पत्थर बोले तो बहुत चीजें लग लेती हैं ये प्रॉब्लम ସେଟା ଗୋଟେ ଅଛି ନା
taking slowly this
स्टार्ट करने की अरे हे
Okay, what we will do is we will do this practical after lesson.
Yes.
We will start the theory.
Correct.
Then all the practical. By that time, if you have problem with this, we will copy paste. So within 10-15 minutes, we can take to know that whether your machine is functioning properly. If it is not functioning properly, get a hard disk and copy the entire image and put it in your machine and start it. Okay, so this is the way we do it. Right? So there is otherwise, simply I will say that you are not doing anything, then that one may not be needed. So we will start with the ASM. So what are the practical, pending that's fine. Do you have anybody about the hard disk? External hard disk? No.
ଆମେ ସେଟାକୁ ଏଇ ଇମେଜଟା ନେଇକି ଆମେ ଘରେ ବି ଇନଷ୍ଟଲ୍ କରିପାରିବୁ
गेम ताको रखेको ता एउटा अप्सन थियो नोड वा नोड जोडा काम करे ता देहरे पेस्ट कर
କାହିଁକି ଆମେ ଟୋଟାଲ ମୋ गेम ରେ ଇନଷ୍ଟଲ୍ କରିଦେଇକି ଏ ତିନିଟା ନୋଡ୍ ବି ପକେଇଦେବା ଆମର ଇନଷ୍ଟଲ୍ କରିବା
कर ना गोटे कर ता
ଆଡିଂ କରି ପଳେଇଲି ଆଡିଂ ତ ବହୁତ ସ୍ଲୋ ହବ ସ୍ଲୋ ଆଡିଂ ସେଟା ଗୋଟେ ଇଏ ରୁ ଲାଗିବ ମେମୋରି
Can you arrange a hard disk?
Yeah, I have
ठीक
Okay, third node, if any problem with the third node, you shut down it and workspace with the node only. Third node, I show you how to add a new node.
नोड 1 था
नोड ऑन द सीक्रेट है
No, node 1, node 2, be
नोड
2 you started thinking right
पेशेंट स्टार्ट
करना पर इसका टाइम लगे होती चलो ओवरऑल कुछ भी नहीं
So we start the theory for ASM. So by that time you try whether everything coming or not. Okay. And what you can do for saving the memory or the CPU is that right. Even though third node working fine, you can shut off. Third node you can safely shut off. So safely shut down the third node and keep it because we are going to work with the two node rack. So whatever the things we are going to demonstrate, everything will demonstrate with two node rack. Correct. So third node is the starting instance which will be starting so will be very so you have one in the performance. So better you do whatever you don't use, you will shut down already. Even though it is working fine,
you need zero.
and the resource which is running in the third node always will be offline, so no need to worry. We are going to start the cycle in a typing now. You can see that the resource which is running in the third node has to be offline, except that only, because third node is not running. Right? Okay, do this thing.
So this sort of thing is not go on, right? Like it is some option is if it finds that node is lost, it will restart only one time.
There is an action, not one time, there is some certain action will be there. So for 10 times or 12 times he will try, but then he will give up. Then he will not try. Because third node anyway is down. HSP will try to invoke it, but sorry, he is not available. So it's practical we will do it. Okay, but to make automation stage. Okay, what are node 1, node 2? So now we are going to start with the ASM, automatic storage management. So this is what very important topic. Automatic storage management. So as you know that ASM, automatic storage management, is a volume management. What is the volume management? Managing the underlying disk. Okay. So prior to ASM, we were using third-party software like Veritas software or hardware RAID mechanism. RAID 0, RAID 1, RAID 5, RAID 10. Like that many mechanisms available for a fault tolerance. So Oracle 10G onwards, they introduced a concept called ASM, automatic storage management. Somehow we are not much happy with the ASM in Oracle 10G because a lot of drawbacks we have seen in the real-time scenario. There are the disk crash and all, taking time for rebalancing operations. So there is a feedback from the customers. So what happened? Oracle 11G onwards, Oracle tried to implement some new solution so that somewhat better than what? Better than Oracle 10G. So customers have started using Oracle 11G release to ASM because n number of new features are there when you are talking about ASM, automatic storage management. Okay, so ASM is a volume manager managing the underlying disk and it's an Oracle product. Okay, so you are going to go for integration in separate in nothing required for it because ASM is a separate coming along with the Oracle product. Okay, so we are going to work with ASM. Why ASM? How the ASM is going to work? See the scenario. I am working with a single instance database. Just take a small example. Working with a single instance database. So this is what my instance O of here. All the instances using a local, location. All the files are stored in the local file system. We know the drawback of the local file system. For example, this is what the /u01 mount pointer, and my d1.dpf and the d2.dpf. All the files are available in which location? Control files, data files, everything available in the u01 mount pointer. This is what my instance. Correct. So if something happens to this local mount point, what will happen? Database availability will not be there, isn't it? So in this example, if the hard disk is highly available, instance is highly available, of course we can go to the hard disk, we can get the data, we can read the data. But if very single point of failure happens, then database is not active. Okay? So this is what is the local file system. It's not a shareable file system, local file. Even the shareable file system also, if the shareable file system works, everything works. Correct? In that case, the solution is hardware level RAID mechanism. But if you are going for a hardware level RAID mechanism like a RAID 1, RAID 10 onward, always the dependency between the hardware system people, they have to. Oracle cannot do anything transparent. Okay. So that's the reason Oracle 10G onwards, Oracle implemented a new concept called Oracle ASM. Okay, is that media manager managing the underlying disk and it's a portable file system. It's very cheaper than compared with any other product in the market. Okay, now just take an example. My manager asking me to configure ASM because of this drawback. What is the drawback we are seeing? Single point of failure affecting the thing. Okay, for avoiding the situation, my manager, my organization decided to go for what? Decided to go for ASM. So I am working as a DBA and I am responsible for configuring the ASM. So what should I do? I have to communicate to my hardware team or procuring the disk. Correct? So we have to get the disk hard disk. So we need to see Oracle certification metrics website and which are the disk authorized by. Some of the storage is not supported by Oracle nowadays, correct? You know that previously Oracle recommending go for HP. Correct. Now Oracle saying that don't go for HP. Correct. Because but they only upgraded Sun and Correct. So they have a Sun, Nextera, so many things. So they want to promote the road. So what are they will say that these are the things you should not use. So we have to see the compatibility. Whether really this hardware is supported or not, we have to see it. So there is a certification metrics website available. So we can see from there which are the hardware supported by Oracle, we can see it. So anyway, I decided to go for an ASM. So I have to get the hard disk and I have to put ASM on the computer. So the first activity is what? We have to get the hard disk. We have to get the disk. Correct. So according to this example, my hardware team given me 3 disks. So disk number 1, disk number 2, disk number 3. So 3 disks are given to me. All the disks will be connected to the media, to the server using a controller card. You know what the controller card was? Correct. So this is the controller card 1, controller card 2, controller card 3. 3 controller cards are available. Just an example, I am saying 3 disks. ASM support 10,000 disks. You can add 10,000 disks in the ASM. Okay, so this was 3 disks. The number of disks and size of the disk will be completely depends on the size of the database and the redundancy. Correct. For example, if the database size is 2 GB, if I want to go for a normal redundancy, minimum size should be 4 GB. Correct. If I want to go for a 2 GB database with a high redundancy, 6 GB. Correct. So that we need to calculate. So accordingly, we need to see that. Okay, but not 6 GB, not 4 GB. We need to more than that because of some other extra configuration we need. But anyway, these are the identical disks. 100 GB, 100 GB, 100 GB, like that. Identical disks are available. My hardware is given. And as I discussed earlier, you can't do anything to the disk because this disk cannot be discovered by ASM. So if you want to discover the disk by ASM, what should I do? I need to create an ASM disk. Correct? So remember first I told you. Correct? So first of all, ask them to partition it. So they will partition it. We should not put any file system because ASM just like a file system. Correct? No? ASM is acting just like a file system only. So you should not format any file system. You simply partition it. So partition this one, all the 3 you always partition. So this is the disk 1, disk 2, disk 3. But the disk 1, disk 3 will not be discovered by ASM software. So what should I do? We need to do the stamping, create disk. You know the command. It's a command. Oracle ASM create disk. Correct? I told you in the first day. Correct? Oracle ASM create disk. Oracle ASM command will be available only when if you install ASM library. RPM, ASM library. Correct? So there are some ASM, library software are available. Some RPM, 3 RPM packages are available. So all these RPM packages completely depend on which kernel, OS kernel. Correct. So using this OS kernel, you can go to Oracle customer support website, or you can go to OTM website. From there you can download it, and you have to install it. As a root user, we have to install it. So once you install the ASM library, then we can make a switch command Oracle ASM. So using the Oracle ASM, what I can do? I can create a Oracle ASM command. I can create a disk ASM. Correct. So there are so many commands. Some of the commands you have seen. Oracle ASM create disk. For what purpose? Creating the disk. Creating ASM. Oracle ASM scan disk. Or initiating the disk. Correct? Scanning the disk means initiating the disk. Oracle ASM list disk. For what purpose? Simply showing the disk. Oracle ASM delete disk. For what purpose? Delete. Fine. Oracle ASM init. Oracle ASM exit. What is this? Oracle ASM exit for making ASM driver down. Making your ASM library or ASM driver down. Oracle ASM init means starting the driver. So this is for starting the driver, this is for stopping the driver. If the driver is down, you can't see the disk. Because the software should be there, the ASM library should be there. So you can stop using the exit command, you can start using the in command. Okay. And there is another command, Oracle ASM, Oracle ASM configure. Oracle ASM configure -I. Okay. I'll show you this one later. I'll show you. Oracle ASM configure -I will ask you, this command will ask you, who is the owner of the driver? Which user is the owner of the driver? Which user is the owner of the driver? Which group is the owner of the driver? ASM admin. ASM admin, correct. And the next one will be whether you want to start the driver automatically while system startup, yes or no? Yes. These are the three things this command will ask you. So we need to configure accordingly.
So it configures what?
It will be the driver configure. Who is the owner of the library? Who is the owner of the driver? And which group is the owner of the driver? And the behavior of the driver. Whether the driver has to come automatically along with what? Along with the OS start. If the living law means not every time you have to start it manually. How to start manually? Unit test. Every time you start for unit test. Then only the AS will come out. Correct. So some basic commands, you can make a note of it, and some basic commands are available.
If you first time you say that yes, I want to start driver along with the booting process.
Then you have to
later can you modify it?
You can anytime. This command anytime you can execute. Right? But don't change that instead of ready you should not make it order. If you are making order, AS will not start. Correct. If you are changing the ownership panel, your AS will never come out. Then OCR file is voting this you cannot read it. Then the class will not come out. That's not a diagnose. They will diagnose where exactly is going. Okay. So anyway, according to this example, they given me 3 disks. What I have done, they only partition it. Then using the command what I have done, stamped it. Then scan it. Then list it. So all the 3 disks are fine. But already I cannot do anything with the disk. So what will I do? Using all the disks. Now I will say that D1, D2, D3, these are ASM disks, which can be discovered by ASM. That's offer. Now what I will do? Using all the 3 disks, I will create a grouping, nothing but a disk group. ASM disk group. ASM disk group. So usually the name of the disk group always will be along with the plus. So plus data. This is the disk group. Okay, so the disk group name is data. Any name you can give X with data. Any name. But by default, data is the name of the disk group. Oracle highlighter a command, minimum you need to work with the 2 disk groups. One disk group is for data file, converter into a file. Another disk group is for flash recovery. You can use 2 disk groups. I can take you work with 1 disk group, no problem. But Oracle highlighter recommend what? Work with the 2 disk groups. So 1 disk group is for what purpose? Keeping your data file, convert file into a file. Means your database. Second disk group is for what purpose? Keeping a FRA, flash recovery area. What do you mean this flash recovery area, FRA? Oracle can see on it, we have a concept called the FRA. What is it?
In case of any flash or damage, we can recover from the either from the last time stamp or.
That is called as a flashback. That's a flashback. This is called as flash recovery area. Flash recovery area. Flash recovery area is a location. Okay, which you deliver using a parameter. Which parameter? DB recovery file tester. Correct. There is a parameter called DB recovery, DB recovery file tester. So using this parameter, we can configure a location for a flash recovery. So all the recovery related files are moving to which location? FRA. What do you mean by recovery related files? All the recovery related files are moving to FRA. What do you mean by recovery related files? Whenever I am taking ASM backups, my ASM backups are moving there. Your archive files are moving there. Okay, and multiplex control files are moving to that particular location. Multiplex read log files are moving to that particular location. There, no? So, and the flashback logs are moving to the FRA. So, all the recovery related files are moving to the flash recovery area. So, very important is there, no? Flash recovery area. How do you specify the location of the flash recovery area? DB underscore create underscore file underscore desktop. Also, you can see the size DB create a file desk underscore size. The flash recovery area size also you can mention that. They will keep on monitored by FRA usages, flash recovery area. So for keeping the flash recovery area, go for a separate disk group. For keeping the database, go for a separate disk group. That is what they are recommending. Correct. So right now I created a disk group called as data. Okay, how to create a disk group? I don't will see it. So we have to create a disk group. So data is a disk group. Now when we are moving to this chapter, there are so many concepts we are explaining, so many terms we are explaining here. Okay, so we are talking about ASM instance, very important thing. Working with ASM instance. Right? So ASM disk and then ASM disk group. ASM disk group. Right? So ASM metadata. ASM redundancy. Right? we have a ASM memory structure as well as background process. ASM memory structure, just like a DB instance, we have a ASM memory structure. Okay, and we have a background process, ASM background process. ASM allocation unit, AU. Right? ASM allocation unit. ASM failure groups. That is a very important concept. ASM failure group. ASM failure group. And we have some algorithms for managing the thing. We have two types of algorithms. We will discuss that later. ASM, we have some certain algorithms. For writing mobile standard, we have some algorithms. We will discuss that later. What are the two algorithms are available? Okay, ASM algorithms are available. Fine. And we have something called fast mirror rethinker. Very important thing, fast mirror rethinker. And this feature is available from Oracle 11.1 onwards. Fast mirror rethinker. This feature is from Oracle 11.1 onwards. Very good feature. Ready? Okay. And we have new features in 11.2. So, a number of new features. Okay. Third-party support. You can keep third-party files. In the previous list, you can keep only Oracle related files. Now you can keep third-party. Your photographs, images, videos, clips, movies, anything you can keep in the network. Okay? Third-party support. There is a special driver called ADVM, ASM Dynamic Volume Manager. ADVM, ASM Dynamic Volume Manager. There is a new file system called ACSL, ASM Cluster File System. ADVM, ASM Dynamic Volume Manager. There is a new file system, ACFS, ASM Cluster File System. ASM Cluster File System. There is a new feature called IDP, Intelligent Data Placement. Okay, Intelligent Data Placement. And we have ACL, Access Control List. ACL, Access Control List. Intelligent Data Placement. Intelligent Data Placement. ACL, Access Control List. Okay. So many terms. When we are discussing, we will see some or other terms after. So first of all, we are going to concentrate on this part, and after that, we will talk about the details. Okay. So first of all, we will see all these things. So this is what a disk group which I created. Disk group is nothing but a group of disks. Correct? So if anybody wants to talk to the disk group, you can talk the disk group only through the ASM instance. So if anybody wants to reach the data, they have to go to the DB instance. Correct? Same way, if anybody wants to reach the data disk group, they have to go through the ASM instance. So we have something called ASM instance. So the ASM instance always will replace ASM in a standalone environment. In a rack environment, it will be plus ASM1 in the node number 1 plus ASM2 in the node number 2. Correct? Plus ASM1 plus ASM2 plus ASM3. Then there are so many ASM instances will be there. So according to this example, plus ASM1. According to our system here, I work with a standalone, so it is a plus ASM. Fine. So if it is a standalone, we will say that it is a non-clustered ASM. If it is ASM is in a rack environment, it is a clustered ASM. What do you mean clustered ASM?
More than
one ASM instance mounting the same disk group. Correct? More than one ASM instance mounting same disk group. You remember, we have a three nodes. In the three node, what happens? Plus ASM1, plus ASM2, plus ASM3. Three ASM instances are available, but all the ASM instances are talking to the same disk group. Correct? Same disk group. That's what a clustered ASM. Non-clustered ASM means what? One-to-one mapping. So one-to-one or one-to-many means one ASM instance, but they will be talking to one disk group or a mini disk group. But other ASM instances cannot talk to this group. Correct? Because it's not a cluster. In a rack environment, it's mandatory that you have to work with a clustered ASM or a non-clustered ASM. You have to work with a clustered ASM. Correct? Fine. So because whenever you want to talk to the disk group, we need an ASM instance. Just like a DB instance, ASM instance also contains the memory structures as well as background process. when I talk about the memory structures in ASM, we have the memory structure called the shared pool, ASM cache, last pool. So these are the three memory structures in ASM. Okay, we have a shared pool, just like a DB instance. Here also we have a shared pool memory, we have a ASM cache memory, and we got last pool. Three memory structures. Same way we have a background process. Okay, so the background process, so the background process are available. For example, we got a background process called RBAL, rebalance. RBAL stands for rebalance. RBAL, rebalance. Rebalance. Very important background.
These three are only mandatory.
No, there are so many. Okay, so RBAL is a background process. We have a ARBN, actual rebalance. ARB stands for actual rebalance. N stands for number. ARB1, ARB2. You can set maximum 11 ARB. And the ARB is the slave of RBAL. ARB, actual rebalance, is a slave process of RBAL. Means RBAL controlling ARB. How many ARB can start? Sorry, how many ARB can start? Maximum 11. Correct, maximum 11. So another background process we have a GMON, group monitor. GMON. GMON stands for group monitor. Fine. We have a PZ9N. Don't ask me the abbreviation for this. Okay, PZ9N. That's the background. Fine. There is a background called MARK, mark. Other than this, there are n number of backgrounds that are available because same binary, correct? Oracle database binary you are using for ASM also. So what happens? Your DB writer, log writer, whatever the background, same background was available, but almost all background was they don't have any work to do. Where in ASM? Because in ASM there are some special background also. Correct? So these are the very important background codes, but don't take it as consideration only 5 background codes are available in ASM. There is n number of background codes are available, but these are the very important background codes. Okay, so RBAL, ARB, GMON, PZ9N, mark, MARK. In the DB instance, which are the background codes? Log writer, GMON, S1, whatever it is. Okay, now we can see one more background code called ASMB. ASM background code. Was the ASMB training? In the diagram. ASMB running the AS instance also. ASMB running the AS instance also, ASMB running the DB instance also. But ASMB very important in which word it is? It's in the DB. Correct? Right? Same also running here also. For example, DB write available here also, DB write available here also. But DB write has nothing to do here. Same way, ASMB here also, ASMB here also. But here ASMB is very important. So ASMB usually we can see in the DB instance. Correct? And these are the background processes running in the ASM instance. Perfectly alright? Okay. Now this is what my database instance, this is what the ASM instance. DB instance and ASM instance should be in the same box. I cannot keep my ASM instance here and a database instance here, let us permanently release that. Not possible. Okay. Oracle 11G release is not possible. 12C they are coming with a feature like a ASM can run somewhere else and a DB can run somewhere else. The new feature coming in the latest version, 12C Android. But anyway, we are talking about it. But according to this example, if I want to go for an ASM, my database instance and ASM instance should be the same machine. So that's the reason if I work with a 2-node reactor, how many DB instances? 2. How many ASM instances you need? 2. Correct? Because wherever the DB instance is there I need a ASM instance. Through that ASM instance you can communicate with the discrete group. Correct? So that's the reason we are expecting, locally we are expecting this way. So this is the ASM instance and that's the DB instance. Perfect. Alright. Okay, so the ASM is ready. This is a memory structure, this is a disk. Everything is ready. Okay. Now my interest is, whenever I am creating the data file in the database instance or a database, it has to be created there. Okay, because I don't want to keep the files in the local file system because I know the risk. If something happens, what happened now? Everything will go. So I don't want to keep the data files in the local file system. So if you have any file in the local system, I can safely migrate using ARM. Using recovery manner, I can migrate it. Now my intention is, when I am creating any data file, the data file I don't want to keep it in the non-ASM file system. I don't want to keep it in the local file system. My intention is I want to keep it where? Correct. So how do you create a file? Create a data file. Create a table space, isn't it? So I'm typing the command from the DB instance and the DBA. I'm typing the command that create a table space. At the same time, even though these two things are in the same machine, there are two different owners. Correct. Who can start a database? This DBA. Correct. Yeah, what is this DBA? So a DBA can start the database, stop the database. But a DBA cannot start and stop the ASM. So if I want to start and stop ASM, we have this ASM. So Oracle 11 servers we have a this DBA as well as this ASM. This DBA and this ASM. He can do anything with the database. He can do with the ASM. Here. This DBA and this ASM to separate the roles are it. Okay. Now I want to create a data file here. So you are typing the command create a table space name data file. So you are going to type out data file. Then after that this group name. I am giving plus data. Correct. Plus data size 10 MB for example. So we are giving this group. Where from you are typing this command? DB or ASM? From the DB instance. Correct. From the database instance, access to DBA, you are typing the command create the table space name data file. You are giving the data file. This is already disk group name. So when you give the disk group name plus data as a disk group name, what happens? Oracle database instance can okay, this file has to be created there in the ASM. Correct. So what will happen? Whenever you are trying to create a new file in a disk group, your ASMB background process will make a request to the ASM instance. Please allocate me some space. So the space allocation order is in the form of an expense. Correct. So 10 MB file I want to create. Correct. For creating the 10 MB file, ASMB background process is sitting inside the DB instance making a request. To whom? To the ASM instance. Okay. For allocating some extender. What to allocate extender? Action has to allocate the disk group. Correct. Okay. Then what will happen? ASM instance will come here and he will allocate some action here. He will allocate some action here. Allocate some action here. Correct. Allocate the extender. Some space reserved. After reserving the space in the disk, means the data will be spread across all the disk because ASM offers typing as well as mirroring. So you know that the redundancy. Because of redundancy, we have a normal, high, and external. So assume that the data disk group is running with a normal redundancy. So what do you mean by that? Yeah. When they are writing a primary copy, there should be a secondary copy. So primary copy will be written in one disk. Secondary copy can write in any one of the disk. But primary copy and secondary copy they never write in the same disk. Particular item, so they are going to write this way. For that purpose, what they will do for the mirroring and for the primary copy or secondary copy, for all the operations they will allocate what? They will allocate an extender. Then they allocate reserving the space in the form of an extender. And after preparing the extender, they will prepare an extend map first. ASM, who preparing the extend map first? ASM preparing an extend map first. What exactly the extend map are naming? Which extends are allocated? Which extends are allocated to whom? DB1.db file. That's what are the data file. Which data file you created? For that particular data file, which are the extents allocated. So that information is there in the extent mapper, and the extent map will be stored where? Stored in the metadata, ASM metadata. Correct. So that is what the ASM metadata. At the same time, this extent map will be given to whom? Extent map will be given to DB. The database should know that what to go and write. Correct. Okay, so the space reserved in the disk and that information given to the DB. So now the database is very much aware about that. What to go and write. Correct. Then what he will do? He will directly come to the disk group first and he will write. Actually, who writes? Database. Who reads? Database. So there is no any structural changes. Whenever there is a need of reading the data from the ASM disk group, who reader? Server process reader. database instance server process read. Whenever there is a need of writing over this ASM instance, who writes? DB writer writes. Correct? No? Database instance DB writer writes. But what the purpose of the ASM? Please keep on monitoring the situation. Correct? No? So whether it is in all the disk 3 disks are working fine or not. If the 3 disks are not working, if one of the disks is crashed, what are the data will be there? So that will be transparently controlled by whom? ASM. Correct? So all things will be monitored by ASM. Now onwards, the ASM instance and the DB instance has to communicate each other. Now there is a dependency. Now if ASM instance gets killed, what happens? DB instance also will get killed because there is a dependency.
If there is dependency, it should not be killed. I think it should give a real acknowledgement like you're not able to retrieve the file or.
It will bounce because always it is mandatory. Now ASM become a passive background process. If something happens with your ASM, we cannot communicate each other. So what happens immediately? There is instance of the bounce.
But ASM is useful in creating a new file.
Not only that, so now onwards, what happens? You will be keeping all that communication, correct? Not only that, reaction time you made a request. And after that, for example, after some time, daemon goes crash. When the daemon goes crash, somebody has to inform you. Daemon, don't come to write in daemon. You write in D2 DP only, correct? So all this communication will be done by the ASM instance and DB instance, coordinated by ASMP background process, correct? So now onwards, ASMP background process will be keep on running which loader? Keep on running in the television, correct? But all the whenever there is a need of communication, the ASM instance will be done by whom? ASMP background process, correct? So you can't just stop your ASMP background process. Clear, no? So the dependency always will be there. If I want to start my database instance, my ASM instance has to come up first. If the ASM instance is not up, what happens? My DB instance will not come up because you stored some files there in the ASM. If you are not keeping any files in ASM, there is no dependency. Otherwise, there will be dependency. Correct. So in this case, this is the way you are going to command later. But really, how we are going to explain it. Okay. So you understood, no? I just indicate which are the extents allocated, which are the extents free. How many disks are available? Correct. So all this information available where? Available in the ASM metadata. Correct. So it is called as ASM metadata. ASM metadata is stored where? Within the distributor. So if you have a 100 GB, 100 GB, 100 GB disk available, total one size 300 GB. This 300 GB you will not get for writing only. Out of 300 GB, some space will be reserved for what purpose? Metadata. Correct. Some percentage will be reserved for the metadata. So don't expect a 100 GB, 100 GB, 100 GB, 300 GB, and all the 300 GB given to us for writing operation. Out of the 300 GB, some space will be reserved for writing the metadata. Correct. The remaining space only available for what purpose? Available for writing operation. So the experiment is prepared, and the database is aware about that, where to come and write. Correct. All the information available. Whenever any changes happen in the structure of the disk group, what happens? Immediately this information will be given to whom?
Metadata.
Given to the DB instance. So the DB instance can react on the disk. We see how the real writing going on. Okay, just take a small example. How we are going to write the data. So this is what the communication process between the ASM instance and the DB instance. You understood? Correct. Now we will measure how the real process is going on. Some metadata, some extents are already allocated. Already allocated. So this is what the method, some space allocated. Who aware about that? Where it is allocated? DB instance. Okay, how come? Because ASM got a message from whom? Take an example. I am going to insert around some particular data, 90 MB data. I am trying to insert. Okay. Since ASM providing mirroring, since ASM providing splicing, what do you expect? The 90 MB data has to be span across all the streets. Okay. So whenever I am trying to write the 90 MB data, the 90 MB data always trying to write in across all the streets. So there is something called as splicing. What do you mean splicing? Spreading the data across multiple disks. But if you want to keep the data across multiple disks, there is some unit, correct? Okay. So the splicing always depends on AU size. There is something called as allocation unit. AU. Okay, allocation unit. The default size of the AU is 1 MB. You remember I showed you during the demo installation, correct? 1 MB. Okay, so default size is 1 MB. It can be 1 MB, 2 MB, 4 MB, 8 MB, 16 MB. Correct? You can configure the same way. When during the demo, disk group creation.
What is the criteria to choose 16 MB?
If you want to go for a bigger exercise, what the criteria in database you are going for bigger exercise? In database we have criteria small X and bigger X, larger rows. Correct? No? So what type of situation we are going to create? I can create a database block size with 8K. I can create a DB block size with 32K. I can create a DB block size with 2K. What's the logic?
2 to the power 4 6
1 MB, right?
Yeah, same logic here.
8 MB.
Yeah, that's what I'm saying. The same criteria I'm talking about. In a database instance, when I'm creating a table space, during the table space, we are going to specify the extent size. Correct? Okay. How we are going to, what type of situation we are going to say that? For example, I am saying 165 for 1 MB. I will be making 2 MB. I will be making it 8 MB. What type of situation you are going to make it like that? Because you know that bigger extent, smaller extent advantages and drawbacks are available. Correct? So if you are using bigger blocks and smaller blocks, what's the drawback? Smaller blocks are always suitable for small rows. Okay, small tables, and only you can do it. Correct? But if your bigger rows, if you are installing the smaller blocks, what will happen? Raw migration, raw chaining, so many things will happen. Correct? No? Same thing applicable for the extender. Same concept. For example, if the size of the AU is 16. At that time, we have to write a 16 MB in one disk, 16 MB in another disk, 16 MB in another disk. Correct? Correct. What do you think? The bigger extent, bigger AU size is good for performance, smaller AU size is good for performance. Smaller AU is good for performance. Correct? Just take an example. I have a 10 disk available. In 10 disk, I am going to specify 2 MB. So what happens? 2 MB can be spread across all the disks. Then next to 2 MB, next to 2 MB, next to 2 MB. Correct? You can do it. But this can be calculated according to the operating system block. Your OS block, many things are coming in the business. But by default, it is coming with the 1 MB. Because one is assuming that smaller extent size is always suitable, but not configure regardless for a bigger extent size. If you are going for a bigger AU size, what will happen? The header will get free only after writing 16 MB. Correct? So every artist they are going to write 16 MB, 16 MB, 16 MB. Correct? They are going to write. Anyway, according to the situation. But according to your requirement, what I can do? I can create a different disk group with a different AU size. Correct? So what is the default AU size? 1 MB is the default AU size. So according to this example, the size ratio always depends on the AU size. What is the size of the data? 90 MB. So what happens? Whenever you are writing 90 MB data in the ASM, the 90 MB data will be converted into the smallest unit called a AU. So how many AU will be there? 90 AU will be there. Correct? 1, 2, 3, 4, 5, 6 like that. How many AU will be there? 90 AU will be there. 90 allocation unit will be there. Okay. Out of this 90 allocation unit, how many disks you are using? 3 disks. What is the NNC? Normal. So what happens here? These 90 allocation units are going to write across all the 3 disks. Correct? So what they will do? They will write a 30 here, 30 here, 30 here. And again, you should not think such a way. First 30, second 30, again next 30. Not like that. I told you that clearly. Typing is in the form of what? Allocation. So 1, 2, 3. Okay, then next one. So the total AU you are expecting what? Expecting 30. So Oracle will try to write the data across all the disks equally, but don't expect everyone equally. Oracle will try to do it, but in case there is a problem, performance issue, bandwidth issue, and what happens, they will write another disk. They will not pay for that. So we are expecting in a real-time scenario, but equally it is writing. But according to the system, I am saying that 30, 30, 30. So whenever they are writing the data, 30, 30, and 30, I am saying that these are the primary copy. Correct? These are the primary copy. At the same time, what is the dependency? 2. Normal means one primary, one secondary. So for this primary, what they will do? They will go for secondary. For this primary, they will go for a secondary. For this primary, they will go for a secondary.
There will be pointers.
No, they are writing the secondary. The real data they are writing a secondary. For this is the secondary. For this is, I am saying an example. This is what they are writing. So whenever they are writing 30 allocation in one disk, okay, for that's a primary. Fine. First time they are writing as a primary. At the same time, for that 30, what they will make in the secondary, somewhere. But the primary AU and secondary AU, they never write in the same disk. They will be writing different. Correct. Take a small example here. So this is the way overall process happening. Now take a small example. Really, how we are going to write the data. So 3 disks are available now. Okay. See the when you are writing the data, this is what allocation unit to 1, isn't it? So when you write the data, you are writing AU1 here, AU2 here, AU3 here. That is what striping, isn't it? So striping is done. Once the striping happens, this is what the primary copy exists. Correct? All is a primary copy. True? For this primary copy, what they will do? They will maintain secondary copy. Correct. So for this primary, they can maintain a secondary, either the secondary or third is right. Depends on the number of words is writing. So they are writing the secondary copy here. For the first AU, secondary copy. For the second AU, secondary copy. Correct? Huh? For third AU, sorry. Correct. They will be writing like this. So the allocation unit, what are the allocation unit they are writing as a primary? What is primary? Secondary will be writing somewhere. So for this AU1, what is the secondary available? Second discuss. For this, for this AU2, what is the available third discuss. For this, it is simplified. Like that, all the allocation unit will be span across interrelated discuss along with the secondary copy. For a single AU, the primary copy and secondary copy never written in the same discuss. This is the concept. Correct? Okay. Now take an example. And all the information there is a metadata. What the metadata available in the header part. Fine? Suddenly what happened? Node number 1, sorry, disk number 1 crash. Correct? What happened now? We have a copy. What's the copy available? In the second is called third is somewhere. Correct? So using that copy, what they will do? They will recreate the data. Or rebalance the data. So what happened now? Even though disk got crashed, the application never came to the information happened. Your database never come down. Because ASM instance transparently handles the situation. Okay, which data is missing, that data will be recreated by ASM instance. Automatically, transparently you will take care of it. So we never feel there is a failure, there is a crash happening. But according to this example, how many disks must be surviving? Minimum 4. Why? Then only normal redundancy. Correct? Normal redundancy. In a high redundancy, how many disks should be surviving? 3. For example, if I have a 10 disk in a normal redundancy, maximum how many disks can get failed? 10. No, pardon. 8. If I work with a 10 disk with a normal redundancy, maximum how many disks can be get failed? 8 disks. Correct. When 8 disks get failed, what happens? Surviving other disks, what they will do? They will require the data, but if you extrude it simultaneously, all the 8 disks simultaneously fail into a secondary copy will be there. Correct. So there is some do's and don'ts. There is a proper quantity to be at a failure group configuration standard, but anyway, this is the way they are going to write the data. Correct. So you understand the concept, no? So they are going to do the striping in the form of what? Allocation. Correct, no? What is the default AU size? 1 MB is the default AU size. You can change the AU size, correct? Okay. So 1 MB is the AU size, and they are going to stripe the data across all the things. So ASM offers striping as well as mirroring. So the data is split across all the disks. At the same time, if anything happens, what they will do?
They will read it.
The mirror copy will be available somewhere else. So what they will do? They will request it. Correct. So this is what the logic behind it. Now see this in the real scenario. How the new disk will be available? New disk?
Suppose our one disk was gone. So how will we get data from this one? Whether disk will be added automatically or
you have a D1 board. You can survey using the D2 disk. You can survey everything. You can survey using D2 disk.
we have to pre-monitor that part. That is this board.
We don't have to do anything. For example, if you have a green survey,
Suppose our disk is
after D1 also restore the board. Because you are not satisfying the that recommendation, correct? D1 2 it is mandated that in a normal redundancy, 2 disks has to be running.
so whether it will alert some error.
No, it will distribute will be discounted. Your distribute data will be go for a unknown situation. You have to go. Yeah, it will affect distributed
Monitor that part.
So you are saying that I am working with 10 disks and all the 10 disks crash. If you are saying something like that, it is not the problem of the ASM, it is the problem of the design. Correct? Nobody can prevent the hard disk to crash. Clear, no? But do you think the hard disk crash will happen every month or every year? Nothing. Correct? So we can say that if a fire or something, some disaster happens, yes, it happens only. Nobody can prevent it. At the same time, in the real scenario, we are not facing the problem of the hard disk crash. We are facing the problem with the logical error, like a switch gone, controller part gone, somebody unplugged the cable, and the disk is having some error. Correct? No? Disk got corrupted. These type of problem we are facing. It will lead for a huge error. Correct? No? So this will be prevented by ASM. So even though it is a major crash, if you are working with 10 disks, if it is a major crash for 5 disks got crash itself. No need to worry, because other 5 disks they will take care of it. Correct? How they are going to take care of that is a different thing, they will maintain it. Okay, but this is a strategy we can do. But all the disks go means nobody can help it. So since I am saying that all the disks crash means definitely something went wrong. All the disks got affected. The media crash or something, some disaster affected all the disks means something went wrong in the design. Correct? So there is a proper logic is applied here in the failure to concept. Right? Right and mirror. Right and mirror. Repeat. Right and mirror is same. Radar is external hardware. Radar 1 and 1 is 1. Zero. This is radar 1 is called as mirror. Radar 0 is called as piping. Okay. Radar 5 is called as parity, and radar 1 0 1 that is mirroring and piping. Hardware.
ASM using a similar concept as radar 5 or
your radar 5 is using a concept. Radar 5 that is a radar 5. Radar 5 is writing in the form of bytes. When you are writing the data, they are writing the bytes. The concept is not a radar 5 is not a mirror copy actually. Radar 5 is not a mirror.
I think it's parity.
It's a parity, but this is not a parity. This is a secondary copy. In the radar 5, how it is? If you need a minimum 3 disks, correct? So in the radar 5 will be, whenever you are writing the data will be converted into smallest unit called byte. So you may have a byte number 1, byte number 2, byte number 3, byte number 4. Same thing. In radar 5 I am talking about. For example, the first byte containing the data 10, second byte containing the data 20. When they are writing the data, the first byte they are writing here, second byte they are writing here. So first byte containing what? 10, second byte containing 20. Okay, so the parity we are writing. Parity is the sum of first byte and second byte. Parity is the sum of the first byte and second byte. So what they will write here? 30. Correct. Now see the scenario. If this particular disk will crash, you don't worry. By 10 is missing, but 30 minus 20, 10. You will get. This is the concept of the radar 5. But in the radar 5, what is the more than what disk will crash? You cannot survive, correct? But ASM you can survive.
No, even here 2 is that's out.
This is become 3, no? What if it's 4? If you have a 4, this is space. Here also I have 4, here also I have 4. What will happen in this case? If first is the second is before crash, what will happen now? You are writing 1, 2, and here you are writing 5. This is a 5. Third, medium 4, you are writing 5. And here you will write what parity? What is parity? 1, 2, 3. Okay, and the parity. What is the parity? 35. 35 you are writing here. Okay, now this also gone. This also gone.
Counting the binary data, 2 parities it will store the time.
Where is 2 parity?
It stores there, it will store 10 plus 20, and 20 plus 5.
No, you can't. More than what is right, definitely it's not a solution. Radar 5 cannot operate. You can't compare this mechanism with our ASM. ASM is a mirrored AU. What are the primary copy you are writing is staying close to copy. We can't compromise. This is not from parity, you are reasoning, use a parity concept.
Parity is like a checksum. It's like
parity means sum of the bytes. What are the bytes you are writing? Okay, the sum of the bytes that is what a parity. They are generating a checksum value. Correct.
Okay, here normal redundancy you are talking about.
So there is separate.
This is, you don't compare with this. This is what is hardware level. You should not see, when I am going to the ASM, no comparison. You should not say that the radar 1 is better than ASM and your any other your Webstack software is better than ASM. Sandbox is better than ASM. You should not do such a comparison. This is an overall product. And this product is built for database, protecting the database. Right? We should not see any comparison with any other product. There may be better products available in the market. Veritas, we cannot compare the Veritas and ASM, because Veritas is having more functionality than ASM. Correct? So, we should.
While designing, we should know that.
Which one?
When our organization says we need to build a brand, we should know whether we should go for ASM or external.
Which one is supported external? For example, you can go in for external Veritas software or some other software standard. How you can do the compatibility and all. Correct.
Generally,
Veritas is a different mechanism, but that will not be shareable.
no, we Oracle or any
You can go for anything. That's what there is a cluster-level file system available in the market. Correct. In a third-party cluster where software are available. CLS file systems are available. If you have a CLS file system, happy you can. Nobody is saying that we have to go for ASM, right? Correct. I'm talking about ASM, that's the reason we are talking about these features.
Generally, external redundancy is article by installation and then it's given to Veritas alias. What I heard. And so we create a disk group. This group is again taken care of Veritas people only.
That is why, because if you are going for external redundancy, there is no mirroring. There is only what? Striping, only striping. Okay, since you have only striping, if any one of the disk got crash, can you protect the data? You cannot protect the data. So ASM cannot protect the data if you are using which redundancy? External. So what can you do? Striping I will do from ASM side, mirroring I will do from external side. Correct. Striping I will do from ASM. Whenever I am writing the data, my data will be spared from which register. Who will take care of it? ASM will take care of it. At the same time, if some of the disks crash, ASM never protected it. Why? Because there is no mirroring. So that mirroring you have to take care of the third party. You don't write anything. You are very tapped or you are even RAID 1.0, any type of things you have. So external redundancy with the third party RAID to combination. Fair enough? Because ASM offers good speed. Why? ASM offers good striping. That's because of striping. Okay, plus protection. Not by done by ASM. Because ASM doing the protection again, it may be somewhat slow, perform slow, correct? So the protection is done by who? So people using the ASM scenario like this, correct? So external redundancy with the third party protection, third party RAID. That is one combination. Okay, but that is possible only which mechanism, which redundancy? External redundancy. Since they are using normal and high, what happens? Normal redundancy and high redundancy always offer mirroring as well as striping, correct? Isn't it? So whenever I am writing the data, according to this example, whenever I am writing the data, my allocation unit when I am writing here, so primary copy of the AU writing here, allocation unit is an image you are writing, it's an extended, correct? You don't compare with your parity, the mechanism is entirely different with the Oracle proprietary architecture. Correct? Okay, that's the reason, keeping your, any other files like, your photograph, images, videos, keeping here, that is not possible. Correct? Okay, Oracle 11 is possible because of some other feature they made. They come up with a new file system for that, for protecting third party. But when you are talking about this type of architecture, you cannot keep your PDF file or Excel sheet here because the architecture is generally different. This is only for what purpose? Only for Oracle database. Your data file, convert, which are the files you can use in ASM? Data file, convert file, regular file, archive file, SP file, flash recovery area. That's all, correct? You cannot keep your P file in the ASM. You cannot keep your password file in the ASM. Your alert log file you cannot keep in the ASM. So there are some processes available. Correct. So this is the way they made it. So here I must say three disks. This one, disk 2, disk 3. So we are writing the allocation unit. The AUs will be spanned across all the disks. Other things, which AU you are writing in disk, that will be mirrored to another disk. It's exactly copy. Okay, it's like, but it will be considered as copy, secondary copy. It is named as secondary copy. Correct. It's not a parity. ASM never done a parity. It's a completely mirroring technology. So if you want to compare, you can compare with the RAID 1.0. Don't compare with the RAID 5. RAID 1.0 offer what? Mirroring also, striping also. ASM also, going for mirroring and striping. But that is file level, OS level, file level, but you read is AU level. Correct. So that variation will be there when I talk about ASM. And this will be completely managed by the ASM instance, whereas radius values in the OS hardware. Correct? No? And in database administrator cannot do anything over that, but here we have a lot of control because all the storages are managed by whom? The storage administrator. Who is the storage administrator here? ASM-DB. Correct? ASM-DB, he can manage the situation. So this is the way it works. Okay. Now overall picture we got, correct? So how they are going to write the data? So initially they are going to do the writing. So once they write the data, then they are going to do the mirroring. It will be very expensive. We agree that, but still, if you are going for a normal NC, it will be very expensive. Now take a small example. When you are writing the data, just see this scenario. I am writing here 10 GB data. Right? Here I am writing 10 GB data. Here also I am writing 10 GB data. Right? So now onwards when I am saying that 10 GB, this 10 GB may include a primary copies as well as secondary copies. Correct? For example, if you are writing 5 GB primary copy, 5 GB secondary will be writing somewhere. When I am writing 5 GB primary copy, 5 GB secondary will be writing here. So when I am saying now onwards 10 GB data means it's including what? Primary copy as well as secondary copy. So total how much data I have written? 10 GB data is written. So out of the 10 GB, some primary AUs will be there, some secondary AUs will be there. Okay, allocation will be there. So this is the way the data span across all the 3 disks. Perfectly alright? And what is the normal instance? Minimum how many disks in a survivor? 2 disks. Now I have a 3 or 4. Many disks are available. Perfectly alright. In this account, just this. Suddenly what happens? Disk number 1 crash. Okay. It's a major, it's not a control card issue. The disk 1 crash. Okay, totally go. What happened now? You have some primary copy, you have some secondary. Correct. Some AUs are primary, some AUs are secondary. Correct. If the AUs are secondary, you don't need to worry, primaries are having somewhere. But if the AUs are primary, you need to worry because only secondaries are having, they are having the secondary. Okay, now I am talking about Oracle 10G. In Oracle 10G, can you please come back again? You written 10 GB, 10 GB, 10 GB data. Right? Contains primary and secondary. Maybe the primary because you are not writing. Yeah, there is no disk only containing primary. There is another disk only containing secondary. Nothing like that. Right? So this 10G can be what? 10G can be primary as well as secondary. Correct. Okay. Now take a small example here. This to one track. Some primaries are missing. Some secondaries are missing. Okay. Now just take an example. After they have taken the common select from table name. Example. Some primary copies are available there. Primary copies. Some primary copies are available for employee table. Some primary copies are available in disk number 1. Are you able to read disk number 1? You are not able to read disk number 1 because primary copies are not available. But no problem. Secondary copies are available there. Some other place. But in Oracle 10G, you cannot read the secondary copy. Even though the secondary copy available, you cannot read the secondary copy. So what we have to do? Using the secondary copy, we have to rebuild the primary copy. That is what we have to do the rebalancing. We have to recreate the data.
So that is a manually.
But that will do taken care of automatically. Okay, that will completely transfer. You will do anything, but that may take some time. Correct? Okay, now take a scenario here. This totally crashed. Okay. ASM instance always expecting a heartbeat from the underlying disk. That is very, very important. Your ASM instance always expecting the heartbeat. Yes, I told you something heartbeat is subscription. So each and every disk, part of the disk group, they have to send a heartbeat to whom? ASM. So in the ASM instance, there are so many background codes are available. So these people are waiting for a heartbeat from whom? ASM. So if the disk group. If the disk are sending the heartbeat, ASM instance will assume that okay, everybody is surviving. There are no issues. At the same time, they will maintain the metadata, ASM metadata. So the ASM metadata says, okay, disk number 1, disk number 2, disk number 3, highly available, online. Correct? This is what the metadata. So everything is perfectly updated. And they very much aware about that. Which are the AUs are available here? Which are the AUs available? Which are the AUs available? Which are the actions allow care free? All the information kept in the metadata. They are very much aware about it. Perfectly okay? Suddenly, note disk number 1 crash. What happened now? He stopped sending heartbeat. Correct. He is not sending the heartbeat. So there is no heartbeat from whom? Disk number 1. So if there is no heartbeat from the disk number 1, what will happen is, G1 background process, he will make his way offline and he will drop it from the disk. The moment some heartbeats are missing, what happens? The moment the heartbeat is missing from any disk, what is the status? The disk become offline, and the offline disk will be dropped from the disk group. Who will do it? So the disk permanently moved out of the disk group. I am showing that moved out of the disk group. Your system is connected. Okay. Same way, this already updated method. So the method has got updated. Only how many disks are surviving? Disk 2 and disk 3 survive.
So this group can
these two disks are available. Fine. At the same time, so who does the activity like the dropping iron? G1. Okay, G1 drop the disk, made it offset and drop it. This is good. Okay. Once the disk gone, problem start. Why? Because some primary areas are available inside, secondary areas are available inside. Correct. Now there is a need of rebalancing. Now what will happen? The RBL background process will give an instruction to this, flavor. Why don't you people go and do the rebalancing? So how many ARB can start? 11. Correct. You can start. So the speed of rebalancing you can control using a parameter ASM power limiter. So there is a parameter ASM power underscore limit parameter in the parameter file. In the ASM parameter file. So the ASM parameter file, there is a parameter called the ASM power limiter. Correct. So using this ASM power limiter parameter, you can control the speed of the rebalancing. In Oracle 10G, if I am giving the value ASM power limiter 1 means 1 RBA will come. If I am giving here 5 means 5 RBA will start. What do you mean by that? Who is performing the rebalancing? ARB. Okay, so but here we are talking about RBA. Who performed it? ARB. So what will happen if you are giving ASM power limiter, this is about the speed of the rebalancing. Who does the rebalancing? ARB. So if you are giving 5 means 5 ARB. If you are giving 2 means 2 ARB. So using this parameter, I am able to control the speed of rebalancing. If you are giving 0 means no ARB, means rebalancing will not taken care of. It is disabled, rebalancing disabled. So the speed of the rebalancing you can control by using which parameter? ASM power limiter. And this parameter has to be updated where? ASM SP5. ASM SP5. Which is the parameter? ASM power limiter parameter. Default value 1. This is R1.
R will just put on this.
R is a coordinator. RBA is a rebalancing coordinator. He never will give an interest is people to learn. Yeah, manager. Secondary control will become manager. Yeah, I will explain. Okay, so here another scenario. Whenever again heartbeat missing, G1 will come and drop the disk from the disk group. When I would update it, immediately RBA will give an instruction to ARB to the rebalancing. What is the rebalancing? I am talking about Oracle 10G. There is a slight difference in 10G and 11G. Okay, 11G release one order and 10G release. Now I am talking about Oracle 10G release 2. In Oracle 10G release 2, what happens? The moment the disk got dropped from the disk group, RBA give an instruction to ARB. Then what ARB do is, they have to go to the secondary copy, wherever the secondary copy available. Maybe the primary copy of the first disk, secondary maybe in the second disk, they never in the single disk, right? It will be spread across both the disks. The secondary copy can be spread across D2 and D3. So what they will do? Using the secondary copy, they will recreate a primary.
Where?
In one of the disks. Correct. Just for the discussion, I am saying that there is an allocation unit to 1, there is an allocation unit to 2. This is secondary, this is secondary. Fine. Were the primaries available? Not available. One is what? This one. Correct. Now what they will do? Using the secondary, they will create a primary. And the primary is not a primary copy. Yes. Using the secondary, they will create a primary. What the primary they will keep? Yes. But because they never keep the primary and secondary in the same disk, correct? So they will do it. But the problem is they have to recreate the data. Correct?
So do we have, after recreating, still we have that secondary copy?
Separately secondary copy has to be made. Using the secondary, you are rebuilding a primary copy.
So primary, secondary,
Yes, you have, yeah, that has to be maintained again. So then you are going to maintain. So according to this example, once the disk once crash, what will happen now? How much data now? How much data one? Physically, how much data? 10 GB. This 10 GB can be, primary and secondary. Now what will happen? Out of this 10 GB, 5 GB will be managed by this guy. 5 GB will be managed by this guy. Means that's what a recreator. The data recreator. So rebalance the data. Okay, now see that there is another issue coming here. So fine. Okay, now see the scenario. If I want to tolerate a single failure, the server in this need
Sufficient space.
for example, if 10 GB available in the first disk, if I want to recreate the 10 GB should be available in
Both are the
server disk together, correct? Not individually. Correct. So if I want to survive a single failure,
we must have sufficient space.
that's how much?
50 GB.
We need a space exactly same as the missing disk. Correct. The first, for example, if the disk capacity is 100 GB, if the 100 GB disk is missing, this 100 GB data should be managed by these two people. Correct. So these two together, disk plus disk together, how much space they need? 100 GB. That's a very important factor.
Size is the same in all the disks, right? Size is the same.
All size are same in components. Exactly.
Can we have different disk of different size?
You have to go for same disk. That's hard to see. I given the image for copy.
Yeah.
Can you get it from? Because I have to copy the image. The external microphone. You understand the concept? For example, you are writing a lot of data here, and what if people there is no space left in the disk number 2 and 3 for managing data? You cannot survive. Essentially, I told you from the beginning, if you have a 300 GB, out of the 300 GB, you cannot utilize all the 300 GB. If the disk group is having 300 GB capacity, you can write only how much data? 50%. 50% correct. So you can go for only the 50%. But really, can you write 50%? No. Why? If everybody is writing 50%, explain the data. If everybody is writing 50%, then it becomes full. Then what about the tolerance? That is not possible. Correct. So what Oracle will do is, Oracle always keep some space for what purpose? Always keep the space for a tolerance. So you can see that how much space is usable. In a 300 GB disk group, how much space is usable, you can see from V.disk group, there is a view available. So in the V.disk group view, it will show you total free space available how much. So if I am saying that total free space available 300 GB, do you think 300 GB you can engage for your write operation? No. Because out of the 300 GB, some space we need to go for a primary copy, some space for a secondary copy, correct? So when I am writing the data 1 GB, you need 2 GB. If I am writing 10 GB, you need 20 GB. Correct, no? In that normal LNC. But if I am going for a higher LNC, when I am writing 10 GB, you need a 30 GB. Correct. If I am writing 20 GB, you need 60 GB. Correct, no? Plus.
Some space of metadata.
That's already explored. I already explored. So free space means you are going to get an X amount of free space with the hard disk. X amount. Okay. Can you write X amount of data inside? No. Okay. So out of this X amount, some space is reserved for what kind of mirroring? How much? 50% is reserved for mirroring. Why? The rest of the 50% you have. Can you utilize the 50% again? No. Why? Out of the 50%, some space you need to keep it. Why? Yeah. For what purpose? If somebody failed, his data I have to take care of it. Correct? Not only me, we all together. Correct? So always what I will do, always apart from the mirroring space, all the disk will maintain space exactly equal to the size of the other disk. That's the calculation. This calculation will be automatically made. Accordingly, only they will allow you to write it. There is no situation like I am writing a lot of data. No, you can write up to this x minus, you are getting some value, there is no y. You can write up to y only. If you are trying to write more than y, you have to add a more disk. Not space, add more disk. Correct. You cannot increase the size of the disk. Correct. Correct. No? You add the disk. You understand what I am saying? Percentage size of the database is 100 GB. Fine. So I kept the 100 GB in 3 disks. And I am doing all the things, so 100 GB full by tolerating all the fail values, they are managing that. Now I want to make it 200 GB. You cannot make it 200 GB. Even though you have free space available, you cannot make it 200 GB. Because the free space which you are able to see, that is for what purpose? That is for a fault toleration. So in that case, what should you do? I will add a mod. So this calculation we can see B dollar ASM distribution. So I will show you that how to see the calculation. B dollar ASM underscore distribution from the record.
So to maintain the recovery area exactly as the size of the messages.
What recovery area?
Where is
You are not maintaining ASM will take care of it. ASM will always ensure that for going by a single point of failure, if I want to tolerate that, how much space I get according to what they will remain, maintain the reserve the space. The remaining space only they will give you for writing operation. Okay, fine. So this is the way they have to maintain. Now take an example here. 5G, 10 GB data load, so what happens? 5 GB written here, 5 GB written here. Then crash happens by 9 AM in the morning. Fine? Okay. Now, after this crash, 9 AM morning, this particular crash happens. After the crash, what happens? I am inserting some more data. For example, I am inserting 6 GB data. So the existing data rebalance. Okay. Again, I am inserting 6 GB data. What happens? One 6 GB data will write. So they will write a 3 GB here, 3 GB there, 3 GB for that. And 3 GB I am saying that including primary copy and secondary copy. Okay, give primary copy there, give primary secondary copy here. Something like that, correct? So 3 GB, 3 GB directly. So this 3 GB is a new data, correct? And these are counted data. Now the method is saying that all the allocation bits are available there in the second and third disk. Now you are in the disk. Why? If more failure happen there, you can't tolerate that. Correct. So I came to, according to this example, we are in a risk activity. So I want to add a new disk. Correct. So if I want to add a new disk, the existing is called a cache, called a permanently code. Correct. So I'm communicating with my hardware team. So what they have done is they give me a new disk. Okay. They already partitioned it and I have done the stamping. Then I am typing the command alter disk group data and it is a new disk name. Alter disk group data and it is a disk name. So what you are going to do? You are adding the disk inside. So you add. Right? So once you add the disk inside, what happens? He starts sending acknowledgement. Method is about updated. Now D1 came. Okay, so what happens? The disk is offline, he starts sending acknowledgement. So once he starts sending acknowledgement, who came to know? RBL background person came to know, okay, there is a new data. Okay, so what will happen? This RBL background is given instruction ARB. Okay, do the rebalancing. What is rebalancing? Personally, two people are sharing the load. Why don't you give some tasks to this way? Don't allow him to sit idle. So what happens in that case? So the total data you return 10 GB, 10 GB, 10 GB, 6 GB. So 36 GB divided by 3. Correct. So what will happen? Again, he will take it 10 GB. Then the 3 GB will happen 2 GB, 2 GB, 2 GB. Don't expect exactly always 2 GB like that, but they will try to do equally. So this is what is the rebalance. So whenever any new disk, you are adding new disk, rebalance will happen. Whenever it is a crash, they will do the rebalance. Correct. So all the tasks will be coordinated by whom? By RBA background. So by this time, no problem with application. Your application will be highly available. Correct. And there is no database crash. Nothing. Everything is transparently going on.
If you are talking about the size of this code,
you can everything see. You can easily wonder, no worry about it. Okay, but the size personally used, how much space are inside, how much is good for the mirroring, how much is usable, okay, all the So you understand the concept? So this is the way the rebalancing is happening. So in Oracle 10G, this is the way it is happening. Oracle 11 is slightly different, but I will explain. So this is the way the data is mirrored.
When it comes to database, huge data, the rebalancing will take time. Then however the performance.
That is what the drawback I told you already. Oracle 10G I told you there is a drawback, correct? What is the drawback? Replicating the data will take, terabyte data, recreating the data will take considerable time. But you have to take, considerable time. For example, if you are saying that it is taking 2 hours, 2 hours, which data will not be available? The data which is going to rebalance that is not available. But it is preventing any customer to do an insert update operation or not? No, no. Who will be getting affected? Only whoever working with the failed extent, they are going to get affected. Correct. But if you are going to do a new insert operation, new update operation, what will happen? My ASM will be allocating new extent in the surviving disk. Is it affecting the application? No. But I agree with you. What if you are reading the data from a failed extent? You cannot read it. You have to wait until each rebalancing. Correct. So throwback, I agree that. Correct. But still better than what? Failure in the database and all. So customers are still able to work, but some of the customers will be getting affected. At the same time, this may be a performance overhead. Which one? Rebalancing may be a performance overhead. But don't need to worry. If you think that doing the rebalancing to the business level, is it an overhead? Why don't you make the ASM power limit parameter 0? Correct. So we are going to make the ASM power limit equal to 0. What do you do that? Rebalancing is not happening. I know that the data availability, some of the data availability will not be there. Okay, let them make for some time. Rebalancing I will do when? After the business level. At the same time, whoever doing the new operation, they can continue to work. Continue with the other disk. Correct. Other disk. Correct. That is up to you whether you want to disable or enable that or.
This will not work. The data itself is not there. How instance will finally
It is.
every time it should be.
Instance never looks for the data. Data is different, instance is different. Instance is only looking for what? Do you think if one of the disks crash, your instance becomes down? No, no.
No, data file is missing. No?
Data file is not missing, but the data file is missing.
Copy is there, no? Copy is creating library.
But the file is missing. Do you think the file is written here? File is not written here. I told you already that you are spreading the extent across all the things. Correct. So if you are writing 100 GB file, 100 GB data file, the 100 GB data file spread across all things. So the 100 GB allocated across all the 3 disks. So whenever one disk is missing, okay, 30 GB is missing. Correct. 30 GB is missing. That 30 GB will be required by whom?
Second data file is
file is not missing. The file is still there. You are playing with the data. But you can make a situation like this. What if somebody deleting the file? It's not a disk crash, deleting the file. Which file? The physical file. Yes. File gone means gone. So it means even though there is no memory code, file, the physical file is gone. Correct. For example, I am going to ASM CMD, deleting the file. It is just like what? You are going to the drive and selecting the file and deleting it. Same way you can delete it. Right?
So you can do it.
You can do it. You can delete the file. But that is different. That is for the media crash. That's a very media crash. We need to what? We need to backups. Correct. You understand the scenario? This is the difference you understood, no? So here, whatever you are writing the data, when you are writing the data spread across all the disks. Instead of writing all the data in a single disk, you are writing across one disk. Even though there is a crash happen to one disk, the data will be managed by server. This is the way.
जीबी थोड़ा इंसर्ट करनी क्योंकि 3 चाहिए এটা ওটা নোটিস আড করনি মানে কোলা করে रीड बना
तो रिकवर करतला ता 10 कला
हां ଏବେ ଟୋଟାଲ ଆମର କେତେ ହେଲା 8 ହେଇଗଲା ତେଣୁ ଯେତେବେଳେ रीड ବାଲାନ୍ସ ହବ ଏଇଟା ନୋଟ ସେଟା ରହିଲା ସେଟା ଇଏ ହବ रीड ବାଲାନ୍ସ
ମୋବାଇଲ ରେ D1 ନୋଟ ଫେଲ କରିଲା
ଏଇଟା ରିପିଟ୍ करता तो तो এটা লিখি নিয়েছি
10 ওটা কর দো
ओ लिखी नहीं है आगे एक फोटो भी रीड हो
You may feel that you may end user will feel that yes, it's taking some time or it's slow. So instead of clear, you will love. Select.
Secondly, also will be
Yes. It's not like a secondary related only. Secondary is also spanning. Yes, break. We'll go.
रेड आमलेट आप भूल रहे